Today our topics will be as follows. In the first lesson we will talk about refactoring, about theory of refactoring, what's the goal, what's the definition, when we should refactor our code. And the second lesson will be about bad code. And in every week we will get one lesson about good code and one lesson about bad code. And I want to start. And first of all, I want to show you this thing from Martin Fowler. Martin Fowler, it's very famous engineer. It's author of books Refactoring, and I think that you can read it by your own. And I absolutely agree with this meaning, because I think that create code, it's not so hard, but it's very hard to create beautiful code. And the first questions is for you. Please answer it in the text channel, in general text channel, because it's opened in my screen. And how do you think? What is the main problem of software development? Sharing the project with someone. We can use Git for it, it's not a problem. Maybe another ideas? Broken codes? Yes, I agree with this. Insufficient planning. Yes. But why we have broken code? And why we have problems with planning? Because of not having a healthy code. Yes. But why we have problems with healthy code? Let me help you. I think the main problem of software engineering, of software development, it's a complexity of systems which we want to create. When programming started in a lot of years ago, I think people had not so complex system like in our time. Now we have frameworks, we have a lot of operation systems, we have very complex domains, and that's why we have a lot of problems with code quality, with planning, with another things, because of complexity. And I think maybe you know, maybe you don't know. The problem is the problems with our brain. What's technology? Yes. The problems is our brain, because average person can hold only about 7 items in working memory. I can remember only 7 objects in one time. And I can forget something. That's why I can't understand some piece of code or someone else. only 7 objects. Some of you maybe can remember more objects in one time. What I mean with remember, you can think about it in the same time. Only 7. Maybe some of you can remember more, but I can remember only 7, and it's a fact from researchers. That's why when we try to read the code, we can remember, we can solve in our brain only 7 variables, for example, but you understand that usually we have more variables in one algorithm. That's why we can't understand this algorithm without some abstractions or someone else. That's why we have a problem, that's why we have a bad code, and I think we should make our code easier, make it more readable. And usually when we try to design some systems, we can have 2 issues. First of all, we can have excessive design. It means that we make the code more flexible and complex than it needs to be. And we can have problems because of it, because we lost the time, we lost the money to create this flexible system, but we don't need this flexibility. For example, we can create little mobile application and just publish it and forget about it. We will not support this application. It's a little system, but sometimes programmers try to create so flexible system because we think that it's cool to create flexible systems, it's cool to use some patterns or something else, and after that we lost a lot of time and can't get some profit because we just publish this application and that's all. If we create excessive design, it will be useful only if we want to support this system, if we want to change something inside it, if we want to create the new version, and if we know that we will just create this system, publish it, and that's all, we will not support it or change something, we don't need excessive design. And sometimes excessive design means that we create repetitive code, duplication code, or something else. And moreover, when we have excessive design, it's very difficult for beginners to understand it. It means that we can't use junior developers to create this system because it's too complex for juniors. Another design issues when we create an adequate design. It's very famous situation when we work in some business in which we have not any time, when we have a lack of time and our customer want to get the application yesterday and we have not time, we have not maybe knowledges to create the system with a normal design. That's why we try to create very bad code, and our goal is it should work. That's all. We don't think about the quality, we don't think about some patterns or architectures just because we have not time for it. And that's why we will have problems if we will support the system, if we will need to change something because we have a very bad code and we can't change it very fast. And the little example from literature, and I can say that in my life I had the example like this. When we try to work very fast, when we try to get the first version of system, and we will have the very bad code in this system and we can't to change it. That's why in a third version we try to rewrite everything, or in fourth version, and it means that after some time this project will be die because we did not do the normal design for it. We did not think about the design and try to create it very fast. That's why if we have such issues in design of systems, software systems, we should use refactoring. I hope that you already know what is it, but let me repeat the correct meaning of this word. Refactoring, it's a process of restructuring existing computer code without changing external behavior. It's very important part. Without changing external behavior. It means that we can change the code of our system, but the usual user interface, for example, should not change. Or maybe we can change the code of our method, little method, and it means that interface of this method should not change. It should have the same name, the same parameters, the same types of parameters. Or we can change the code inside our class, but the list of methods, the name of class and the parameters of it should not be changed. I try to explain you that we can have refactoring in several layers. We can refactor little piece of code, we can refactor some model maybe, or class, we can refactor the whole system, but external behavior should not change. If we refactor the whole system, we should not change the UI. If we refactor the class, we should not change the list of methods and parameters of it and the list of fields. If we refactor one little method, we should not change the name of this method and list of parameters of this method. And the goal of refactoring is improve code readability and reduce complexity. If you rewrite the method but readability of this method will not change, it means that you did not refactor it. You just changed the code. It's not refactoring. We should make our code more simple, more beautiful, and more readability. I hope it's clear. And again, about refactoring, the goal of refactoring. Our goal is simplify the understanding, simplify the modification of software without changing the behavior. It means that if we know that we will not support the system, if we will not add some new functionality to some system, it means that we should not refactor it. It's stupid work because we will not add something to this project. We should not have beautiful code inside it. Only just for training you can refactor this system. Then refactor allows us to simplify new code, to improve existing code, and in the next lesson we will see what is beautiful code, how we can improve it. We can achieve a better understanding of the code, and I think it can solve the problem with sharing project with someone. About this problem Benjamin Toro write in chat. Because when we have a very simple code, it's very simple to understand it, and it means that every teammate will know about this code, and if you will go to the holidays, for example, your teammate can solve your tasks. Then refactoring allows us to make the code less annoying. It means that when we try to merge our branch to the main or master, if we have good code with good quality, it increases the possibility that we will have not merge conflicts inside it. And I think it can less annoying. And we can find the bugs when we try to refactor our code, because we make our code more understandable. And if code is simple, it's more easier for us to find bugs inside this code without running our application. We just read the code of application and I see the bug inside it in this line. Look, let me fix it. When should we refactor? About this question, I found several opinions in the books, and the first opinion, it's a rule of 3 blows. Maybe you can tell that it's strange, but sometimes I work with this rule, and I think it's useful. It means that when we do something in the first time, we do it. For example, I need to create some functionality in my application. I just create it and that's all. After that, I need to create another functionality, but I understand that it has the same part of code. And I just create the new functionality and repeat this part of code. But if I will need to create new functionality in the third time, I will start refactoring to move this repeatable part of code to special place and reuse it in all 3 use cases. Again, in the first time, we just make our code. In the second time, we just repeat it and just make our code. But if we should create something the same in the third time, it means that we should refactor our code and move repeatable parts in a special method and reuse it. I hope that if you have any questions, just write to the chat. It's opened in my screen, I can see it, and I will answer your questions. And the second opinion, it's allocate time for refactoring every day. It's like cleaning your room. If you will forget to clean your room after some days, you will live in a very bad place. With refactoring, we have the same situation. You should allocate little time, like 30 minutes or maybe 1 hour every day, and refactor some part of your system. And it means that you will have some order, some good quality in all your system every day, just because you support this good quality. It's another opinion. Sometimes I try to implement this opinion, but for me it's very hard. Because I have a lot of very fast tasks, and it's very hard for me to allocate time, because I have lectures with students, work tasks with programmers, mobile applications, and moreover, it's very hard to allocate time. That's why usually I use first issue with first opinion and just repeat bad code twice, and after that, if I need to repeat something in a third time, I refactor this part of system. And again, some opinions about when we when we need to refactor our system. Sometimes we need refactoring when we create, when we need new need to add new functionality. I open my project, I open the class in which I want to add new functionality, and I understand that I have a bad code here. It means that first of all I need to refactor this code, and only after that I will add new functionality. And usually if I refactor code, I will need less time to add new functionality. Sometimes we need refactoring when we need to fix the error or bugs because when we have a good code, it's easier for us to fix the bugs. And sometimes we need refactoring when we try to explain our code to our colleagues or to our teammates. For example, when we have a code review process. And it's better to refactor the code and help your teammates to understand what you implemented. But very famous problem when we talk about the refactoring in business, how to explain, how to justify the need of refactoring to management. Because some managers can told you that the main thing for them is quality, but it's not true. The main things for every manager, I can tell you, like manager, it's a work schedule and money. And usually refactoring, it's a process which managers don't like, because refactoring has not any results in behavior of application. Manager can't to show your system to customer and say that, look, we create new feature, or look, we change something. After refactoring, manager can't do it. That's why sometimes customer does not understand why he or she should pay for refactoring. Nothing changed. Why I should pay for it? That's why if you understand that your system needs refactoring, you should talk with you managers in a money language. It's very simple. Refactoring, it's like a credit card. You can pay now or you can pay in future. But like with a credit card, if you will pay in the future, you should pay more than today, because you will have the debts. If you will refactor your system now, it means that you will need less money to add new functionality, to change something. But if you will not refactor now, it means that in future you will need more time to add something, you will need more time to change the behavior of your system, and it will be cost more money. Usually every manager understands this little thing and allows your team to spend some time to refactor your code. But we have little situation when we don't need the refactoring. And the example I have in this little picture with kittens, it's about bugs, but refactoring is the same in this situation. The main example, if we need to rewrite a program from scratch, sometimes we have so terrible existing code that we will need less time to rewrite it from the scratch than to refactor it. Sometimes we don't need to refactor the code which does not work. If we refactor something, it means that this code should work. If you have the code with problems, with errors, you should not refactor it, because you can't to check that you did not broke something with your refactoring. That's why I ask you to use working projects for your laboratories project. It's better not to start refactor process if tomorrow we release our project, because we can make new bugs with our refactoring. And I shown you the issues with design. Sometimes we have very complex design, sometimes we have problems with design, and what we should to do. I think that we should to find some balance between complex design and using of refactoring. And we can create some acceptable solution, maybe with some problems, but we can refactor it in the future. And I think it's better than create very complex, very flexible design and have a lot of problems with work with it, with understand this design. That's why I recommended you when you will create your systems or diploma thesis or something else, just create acceptable solution and improve this solution after implementation with small refactoring. Did you have in the previous semester the course of design patterns? Guys, it's a question. Did you have this discipline? Very good. It means that you already know what is it. Maybe you wrote this book. I recommended you to read this book. And you should know what is the patterns, what is the design patterns, and you should know that each pattern it's a special rule expressing the relationship between context, problem, and solution. And it's very good solution of some problems, but sometimes we have the problems of using it because some people don't understand this idea correctly. For example, in this slide I have a little part of a big system. Of course, it was created just for fun, but this is an application in Java, and this application consists all 24 patterns from this book. But the goal of this application is to print hello world. And the size of this application, the line count of it, more than 1,000 of lines of code. Just because the author of this code wants to use all patterns from this book. It's just for fun. It was little experiment, but it's a good example how the using of design patterns can make our code more complex than we need. This application should just print hello world, but because of using of patterns, it has a lot of lines of code. It's very hard to understand how it works, and I think it's a problem for everyone. And I try to explain you that sometimes we don't need to use patterns if we don't need some flexibility in a special part of our system. And in this slide, I have a little example. In the top of the slide, I have a diagram of pattern. It's a composite. And this diagram is from a book about patterns, and it's implementation of this pattern by default. We have a component, we have composite, we have leaf, client, and another classes. But in the bottom of my screen, I have another implementation of composite just with one class. And sometimes students think that if we have in a book about patterns the top implementation, the top variant of implementation, we should always create all of these class. It's not true. We can use just idea of pattern from the book and change the implementation. And in the bottom of my slide, I have another variant how I can implement the composite, and it's a composite. It's a real pattern, and it implements the idea of this pattern, and it allows me to create the hierarchy of object, and it's absolutely normal composite. It means that if I want to add some flexibility to my system, it's not necessary to create all class from the book. I can use just part of this hierarchy, just part of idea, and it's normal. So try to think a little about your system when you try to use design patterns. Do you need this flexibility in this part of code or not? Maybe you can use just little part of idea of this pattern, and you will create understandable, beautiful code with some little flexibility, which is enough for your system. And when we talk about refactoring, we can separate refactoring process into 3 directions. First of all, when we refactor some part of our code, we can do it to patterns. It means that we add new design pattern into our code. Sometimes we can refactor our code in the direction of patterns. It means that we begin to implement the pattern but not complete this process. We just use some part of patterns or maybe some part of idea, and it's absolutely normal. Sometimes we need to remove the pattern from our system because, for example, we thought on the start of our project that here in this model we need some flexibility, but after implementation we understood that we don't need the flexibility here. The same famous example when we try to remove the singleton from our system because we don't need the singleton. We can create more than one sessions or someone else or something else. And sometimes, and I think that it's the most famous variant of refactoring, we refactor without influence of patterns. We just move the method or separate it into parts. We rename something, we change the structure of our class or something else. It's not about patterns. We just create the structure of our programming. And please don't forget, without changing of behavior. And it's the end of the first part of my lecture.